And many thanks to our community program commit members. It's Alyssa and Alexei, people who cares about talk quality on this event. And many thanks to our partners, Awenga, Sombra, and Grid Dynamics. Also, thanks to our community partner, feel free to fill up the feedback form and you will get a chance to win one JetBrains license for free. And today we support IT St. Nicholas Day. You can scan this QR code to donate to this charitable organization. Also, we post the link in our chat below. And also the best questions will get some activity bonus from us. So be active and enjoy your talk. Bye-bye.
Hello, welcome to CoffeeJUG session. My name is Konstantine. I'm a senior software engineer. Today I'm going to share my experience of one of the projects that I've built in the past using AWS. This is going to be like an introduction into the world of AWS and cloud. So I'm not going to tell about some really complex in-depth aspects. And the project idea was quite a simple, which I think it's good to be an example for talking about cloud. So let's start. First of all, we are talk about why we decided to on-premises. At that time, we had both capabilities. What are the costs of the infrastructure? I will tell about the project architecture, and we will talk about some aspects of it, like security, high availability, and the way how we develop it and deploy. I will bring some attention on drawbacks of that and suggest you what to learn if you want to start your journey with AWS. So why cloud? Before we start talking about technical aspects, let me tell you about the idea of the project. That was a really simple project. So we need to host some static content, like some videos and PDFs. The reason was mostly marketing promotions. So we need to prepare some content, add this content to the application. So user should be able to watch the videos, user should be able to download the PDFs and make more purchases. That's it. So we have someone from our site who wants to upload it. It's could be admin. And users should be able to find the content. We are not going to build a really complex search engine. It was something like, give me the content for a particular date, or give me just last 10 videos or PDF brochures. That's it. If we look at it more deeply, we can split it into the content part. It's like we want to store the PDF and video files and provide it to users. And we want to keep the metadata about it. Metadata is the title, some description tags, maybe upload date, really simple search keywords. So something that is not the content itself. And when we upload some new marketing promotion, we want several videos, several PDFs, then we put some metadata, so user should be able to find it. Actually, why cloud? First of all, cloud provides a CDN service where we can keep the static content. So CDN is not a specific feature of AWS. There are other providers of it. But if we have some other things we can leverage from AWS, that's a good point to take a look into that direction. When we use cloud, we pay per use. We don't have the infrastructure maintenance efforts, and like lots of things are automatically. And we have a lot of interesting features out of the box. So let's start from CDN. So CDN is a content delivery network. What does that mean? Imagine we have some server at some location. Like we have a server in Lviv and we want to host the content for the next, this presentation, and let anyone in the world download it. So assume we have a lot of people in the world who are interested in the content. So AWS already placed mirror servers everywhere in the world. They're called edge servers. And the content is downloaded automatically to edge servers in different locations. Then clients from different parts of the world, they may connect to the nearest edge server and get those content. So that means they do not hit our server that is located in Lviv. If they do it, they will have a connectivity. They may have a connectivity issues if they connect from Australia or like South America, or also our server might not be able to handle such a load. And CDN helps us. In AWS, there is a CDN service called CloudFront that is available out of the box. Okay, let's talk about pay-per-use and let's talk about servers. So initially we were thinking, do we want to host it on a server, like make a microservice, deploy it somewhere on the box and run it, or do we want to use something else? So every project, if we want to host any service, we need at least one box. Let it be a virtual machine or physical box. Of course, in more cases, it's just a virtual machine. So if we want to handle more load, we need to horizontally scale it. So we need to put multiple machines. If we need to make it highly available, we need to put it into the multiple data centers. Like, of course, data center 1 may handle 100% of the load, but what if the data center 1 goes down? Or the network connectivity to data center 1 is unstable. So we need to reroute the users to the data center 2. Also, we may have a separation between paying customers and free customers. In our case, that's my previous company, not the current one. In our case, we had clear separation. So we didn't want the free customers to use the same infrastructure that is used by paying customers. The reason was not to keep the quality of service for paying customers high, because we may have a marketing promotions like free trials. There are a lot of free users joining the opening accounts using the service, and we don't want to impact the customers who are paying money. So we need to double that infrastructure. And also we need to keep the different development environments, like we have dev, QA, UAT environment, and we have prod. So if we want to host a really simple application, if we want to handle all the requirements, security, performance, high availability, we need 22 instances. And we need to have spend a lot of efforts for maintaining it. Like we need to configure certificates, we need to deploy, we need to collect the logs, install the packages, do monitoring. And this looks like a really heavy thing, but we just need a service that providing the PDFs and videos, that's it. So I don't want to build something heavy using 22 instances just for it. And this is where the AWS Lambda can help us. So what is Lambda? Instead of thinking of server and application, we may think of functions. So we may write a function, for example, called handle request. And we may use a different language and deploy it as a different runtime. So for example, we may write a code in Java or Node.js, and all that code can be executed by AWS. And Lambda is done in a way so your function is processing some input events. For example, users execute HTTP calls, and one HTTP call is one input event. And also it producing the output events. Like if we get an HTTP request, we query the database, we've got the list of PDFs or videos, and then we send the response back. So this is the output event. And of course, Lambda could be more generic. It cannot be only used by HTTP. It can be used, for example, for queue processing, but this is the general way how it works. And it all provides auto scaling out of the box. So we may have many events, and AWS automatically starts many instances that are running our Lambda function. If we have fewer events, so assume that is not peak time, like it could be night when users are not active, AWS automatically stop the instances. If we have no events, no one is calling the Lambda, AWS stops all the instances. So there is nothing running at all. And only when the new customer arrives, AWS runs the new instance that starts executing the function. So it's done automatically by AWS, all the infrastructure stuff. There could be a problem here because first time when it runs the instance and to be able to process the Lambda function, then we may have some delay. In my experience, there could be several second delay if we have a Java application, if we use some frameworks, or it could be like few 100 millisecond delay first time. And then I've got like 50 millisecond response time after it creates. So it's not a big problem. But if you are sensitive to it, there is a way to handle that. It's called keep it warm. So we may ask AWS to keep particular number of instances of your function always running and pay for it additional money. So it's okay, we can handle this. Here I've put together some numbers. Let's say we have 1 million requests. So it's about $17 per 1 million request. These numbers are not up to date, but you may always go to AWS pricing and see what the current price is. So we say we pay $17 for 1 million requests and we don't need to worry about any service. That's great. There is no infrastructure maintenance. We pay per number of calls. So if no one calls in the Lambda, we're not going to pay anything. It's highly available and auto-scaled. And this technology is called serverless. But serverless doesn't mean there are no servers. That means we don't have any control over servers. We only say, I have a function, I deploy it, and the function processing my request. And there are servers that are managed by AWS. So again, serverless doesn't mean without servers. It means the level of responsibility of us and level of responsibility of the AWS. Okay, let's talk about some other interesting features in AWS we can leverage for it. One of the service is called API Gateway. It's like a proxy between all the client requests and everything we have on our end. We may define routes, and also we may pay. We are paying per number of calls. So like we define for particular URL, like /content/PDF, please call my find PDF Lambda. For /content/video, please call my find video Lambda. And we may call anything. It's not only for Lambdas. We may call any downstream service. It has other interesting features like authentication and caching. So authentication allows us to plug in another Lambda function that is gonna authenticate users. So we can call some auth service that we already have and plug it in this functionality into the API gateway. And it has a cache. Cache is a really, really mature feature. So assume what we provide to users is really static data. So if the user wants to find some content for particular date, it's really something that can be cached really well. So we may enable cache. It's just one property, and we may reduce the costs, and we may reduce the response time, reduce the cost, and increase like the usability. Also, AWS provides a DynamoDB. So I'm not going to talk in deep about that, but I think that the DynamoDB is really simple solution for simple things. We actually put few hundreds information about a few hundreds PDFs or videos into that, so we didn't use heavy at that time. We need to put the static content somewhere. So we may use S3 service. It's called Simple Storage Service. It also has lots of measures for high availability. Like we may replicate this data across multiple regions doing the backups. We may enable versioning just in case we upload some bad data. We may roll back to the previous version. And it has other security measures. So we'll talk about security a little bit later. And there is a service called Simple Queue Service. It's just a queue. So you create a queue, you may put something in the queue, you may get something out of the queue. There are different ways you can configure it. If you need exactly once delivery or not. So you may have a trade-off between throughput and the delivery guarantees here. And what is good thing, it supports retries. You may configure dead letter queues. Another service is SNS. It's like a notification service. We used it for a really simple use case. When someone uploads the content, we just want a simple email notification. But again, it doesn't provide a mature functionality. It's more generic stuff. So you may reroute any notification to any source. And having all that services, we need to find the logs somewhere. So we need to check if there are any errors or to get access log. And logs are also in the cloud. So if we need to find the logs, we need to go to the CloudWatch. And from every service that we have, we may configure the streaming the logs to the CloudWatch. And we may read the logs, we may configure alarms and dashboards, and we may even configure alerts, and everything is managed by AWS. Okay, we briefly mentioned different services. So let me talk a little bit about the infrastructure cost, and then we continue talking about the project itself. So if you want to compute it, there is a web page called calculator.aws. So this is my estimation. If we have like 10,000 concurrent users, which is pretty heavy load, and they're active 10 hours a day, They have one service call per minute, so assume this is a marketing content and users do not really call it really often. So we can see that there is a difference between if we have a cache or if we don't have a cache, so cache can significantly reduce the infrastructure costs. And if we compare it to if we span the EC2 instances, we can see that EC2 instances are just a little bit more expensive than we use Lambdas plus cache. That means this serverless stuff cannot always be cheaper than using traditional instances, but in terms of just infrastructure cost. But the more benefit of it is so you are not able to manage it yourself. And this is always a trade-off. So whether you need to choose serverless or you need to choose your own service, it depends on your needs. So for some of the use cases, having this Lambdas and API gateways becomes extremely expensive. So use this calculator and think of your resource usage in advance. Okay, let's talk about the project architecture. So this is the high-level architecture. You see, it's not very complex. So what we have here, we have the admin user who uploads the content to the S3 bucket. S3 is a storage service. Then we have the Lambda that is handling that content. So S3 allows us to subscribe on events. So once the user uploads the content, we get event. We may configure the queue and we may connect it to the Lambda. So Lambda function subscribing to the queue and storing the content to DynamoDB and copies this to the separate bucket. It's called distribution bucket. Also, we can send the email to admin mentioning that new content is already published. Then we have the functionality that allows users to find the content. So we have the Lambda functions called find content Lambda that makes a queries to the DynamoDB. And we also have the authorizer Lambda. It allows to plug in the authentication. In our case, we had the on-premise SSO service, and we connected Lambda to that service. All that Lambdas I sit behind the API gateway. And we have the static content distribution part. It is the CDN CloudFront distribution. It is the CDN service I mentioned in the beginning. And this CDN service is connected to the distribution bucket. So having all that, we are able to upload the content, we're able to find for it, and we're able to download it. Okay, once we cover the project details, so let's make a little bit deep dive into such aspects as security and high availability. So there are a lot of security measures that exist in AWS, and here I've mentioned only some of them. So this is a really deep topic. Let me mention a few things that I think are more important. First of all, we want to protect from bad guys. So bad guys is someone who are sending too many requests to the server and doesn't bring us enough money. I don't know like why they do that, but that could happen. For example, they may run a DDoS attack. So for that kind of things, AWS has a WAF and Shield services. WAF is a web application firewall. So it may block or allow access to particular endpoints. We can define some rules, access control level rules. For example, we may prevent users from uploading some malicious content. And also we may do some IP address restrictions. Actually, this is the way how we can manage the non-production environment. So we want non-production environment to only be accessible from restricted list of IP addresses. So we can configure it here. And Shield is the service that automatically protects from DDoS attacks. So you can enable shield just really easy. It's not something that should be like highly tunable. Okay, so we know how to protect from bad guys, but also we only want authenticated users to access the system. We have in this project, first of all is assigned URI. So for example, we want to host some video on the CloudFront, and we want to only authenticated users to be able to download the video. And CloudFront and CDN is something that is completely separate from our infrastructure. So if every user downloads the video, it should hit our SSO endpoint. We may be in trouble because there could be like thousands of users downloading the video, and we may not tolerate calling the authentication endpoint each time. So for that, we may and when we generate a URL link for downloading the video, we define the expiration time and we define a signature. So find content Lambda signs the URI using the private key. And then when the user goes to by this URL, it goes to the CloudFront, and CloudFront distribution has access to the public key that allows to validate the signature. So if user modified the URL, or if user doesn't provide a signature at all, or if user modified the expiration time, then CloudFront rejects the call. This mechanism allows to generate something kind of a temporary link. So we may create a link that is valid for 10 minutes or 1 day, and the user will not be able to reuse this link later, like post into his personal blog or download the content later. This is the way used a lot for protecting the static content. Also, the API gateway provides authentication. We were talking about that before. Okay, and once we have protection from bad guys, we have all the authentication measures. Then we want to make sure that the data we put into the cloud is secured. In our case, marketing content was mostly a public data, but imagine if you have some database of the customers and you want to store it in the cloud. That means you host your database in the organization, like inside AWS, and that's your secret. So the only way to securely store something in the different organization is encryption. So we have encryption at every service, and another stuff is how we can store the secret management. So for encryption, there is a service called KMS, Key Management Service. We can generate key pairs, and we can enable encryption for, I think, mostly every server that AWS provides. For example, that could be an S3 bucket. That could be DynamoDB table or CloudWatch log group. So its link is needed. You just enable it. That means physically, when your content, when your data is stored on the AWS servers, it is encrypted. So even if anyone gets access to the service, download the data, this bad guy may not be able to use it because only you know how to decrypt it. And if we want to store some secrets, for example, we want to store the private key from the cloud. We definitely don't want to put it together with Lambda function code because it's insecure. We want to store it somewhere and let the Lambda request it. So there is a service called Secret Manager. You can put any data into Secret Manager and configure your resources to be able to access this data. For example, we may configure that the find content Lambda only able to read the CloudFront signing key, but is not able to read anything else. And you may use it not for Lambdas, you may use it for any services. It's like there are similar solutions that exist not in the cloud for such a purpose as like credentials and secrets management. Okay, and in general, we want access to only permitted. So what does that mean? We don't want the Lambda function that is reading from the database to also write into the database. Just in case someone is hacking our code, we don't want this code to write to the database and delete the data. For that purpose, there is a mechanism called IAM roles and policies. So we define IAM roles and assign it to different resources. And we define the policies inside the roles. And we define, like, for example, our Lambda has the particular role that allows it to read the data from DynamoDB and use particular encryption key. And then we configure API gateway to trust that role. That means API gateway will be able to call that Lambda. This is like a role permission role scheme between multiple AWS services. Like here you see it for the Lambda, and here you see it for API gateway and for the key management service. Okay, so once we're talking about security, let's briefly talk on how AWS handles the high availability. So AWS provides many regions. This picture may be quite outdated because it's done like 1 year ago. Assume now there are more regions. And you may host your applications in multiple regions. Each region is separated into the availability zones. And if we're talking about the serverless services, you shouldn't worry about it. So like if you create API gateway, it automatically runs in a multiple availability zones. If you do Lambdas, it's both. If one availability zone goes down, your service is still working. But if the region goes down, of course, in that case, and there is a question here. If I have deployed my application region A and region B, how do I split the traffic between those regions? For that purpose, you can use Route 53. This is actually one of the ways to do that. Of course, you may use any other ways to split traffic between regions. It's just an example. So you may create a rules and that allow to distribute the traffic between multiple regions. And in case region goes down, the Route 53 health check is failed, all the traffic goes to the health region. Of course, the DNS has advantages and disadvantages. So this is just the only one way we can do this. And this is how the project architecture looks like if we consider it as multi-region. So we have the Route 53 that is balancing the traffic between two regions, between two API gateways. Then we have the CloudFront distribution, and you may put the content into the R3 bucket, and you may configure the cross-region replication for that bucket and connect it to the CloudFront distribution. So that means if one region goes down, your content still will be served. And for the database, it is possible to configure also the cross-region replication. It's called the global table in DynamoDB. Of course, this is the really true eventual consistency. It doesn't fit for many use cases. In our case, we are mostly appending the new data, and we are using one region as a primary, another one as failover. So, for example, we always have a replication from region 1 to region 2. Data is mostly read-only, so we were totally fine with this approach. So what happens if one of the services goes down? So we built an architecture in a way to be fault tolerance, but what is the motivation for AWS to keep the service running? This is an example of one of the outages that I personally saw. So there is a web page called status.awsamazon.com. And at that day, there were a lot of services down, and different companies were posting in the Twitter that, hey guys, we having issues. It's because of the AWS. So the problem there happens. and everything may fail. And here also sometimes AWS is posting a report of what's going on and how they're working on it. For any service in AWS, almost any service, they have a concept called service level agreements, SLA. So for example, you may go for API gateway and you see that if availability is less than 95%, like less than 95% of the calls were served, you completely not paying for the service in the bidding period. That means if the services are unstable, AWS gives you a big discounts. So this is motivates them to keep it running. And you can use this SLA information to be able to check if the system that you build, if the SLA that you want to guarantee can be achieved. So because you are building it on the components that's provided by AWS and have their own SLA. Okay, let me mention a few things of how we develop and deploy. So we were in that time we were using AWS SAM. It's the framework for developing the Lambda functions. So it runs a Docker container on your machine, and when you develop a Lambda functions, you are be able to execute the Lambda functions locally and run and debug. This is a really good feature because in the otherwise you have to always deploy to AWS. You don't need to do it. And that framework also allows you to deploy it easily to AWS. But the biggest benefit is ability to run and deploy locally. We're using infrastructure as a code. It's Terraform. We're using just the standard Java tools like Maven, and we're using Jenkins. So this is pretty standard. Okay. I've mentioned a lot of good things about cloud. So a few drawbacks. Of course, cloud is not for you, could be not for you for various reasons, like you may not share your data with third party, or cloud is always 100% vendor lock. I mean, the serverless, all that Lambdas, API gateway. If you need to move away from AWS to Google Cloud, you need to rewrite your application completely. Sometimes it could be extremely high costs compared to traditional servers. Like you need to use calculator.aws to estimate your costs. In some cases, having traditional servers is much more cheaper. So be careful with that. And of course, it's not about the ultra low latency because there are a bunch of abstractions around your resources. Okay. So let me share my findings of what you can, which resources you can use to learn more about it. I found a really good course on Udemy. It's called AWS Certified Solution Architect Associate. You don't have to worry about certification itself. For me, it was the way of learning things. I didn't have a goal to pass certification at all. And there are also good courses at the iCloud Guru. I think some of them are made at the practical lab. So I think there's both are good entry points to start. And of course, there are a bunch of other tools for the local Lambda development. Like there is a serverless framework, there's a local stack. So it's not only SAM. And by the way, we only tried AWS SAM, but feel free to try any other tools. Okay. Thank you very much, and glad to you have a time for this talk, and I'm ready to answer your questions. Okay, let me check if there are any questions. So I'm reading this, the question, the live chat under the YouTube translation. So, okay, what environment impact the suggested solution has compared with other solutions? If you have a chance to little bit put more context in the question, I would be happy. We compared mostly the environment, the on-premises environment. In our company, there were traditional servers, and we were thinking of using the Lambda functions. And I put a comparison between the Lambda functions and EC2 instances. You can find it in the presentation. Let me put it back. Unfortunately, I'm not sure of the cost that we had having our on-premises infrastructure. But as you can see, Lambdas can be more expensive than traditional services if you don't tune it well, and can be comparable to traditional services. So I think the most impact is how quick are you? Yeah, this is the slide. So how quick are you actually develop? But in terms of cost, it's not always cheaper. Okay, next question. Are there any best practices to combine serverless with cloud-hosted and on-premise approaches? What approach is better suited for particular services? In our case, we have almost all the infrastructure on premises. Like, that was not a new company, and we were like starting adopting the cloud. So I'm not sure what are the best practices. In our case, there was a challenge of connecting all that together. Like, there are different security boundaries. For example, we are living in the cloud world and we are living in the on-premises, so we don't want the software developed in cloud to be able to call anything on premises without a permission. So we had a lot of conversation with securities. There are a lot of firewalls, security groups everywhere. So I think it's, from my point of view, it's really specific to your organization of how you actually able to do that. We were not talking about to do it in the best way. We're talking about, okay, what are the way we actually can do that? Okay, have you had situations when a solution using DynamoDB had to be written to another database? I think we had, but not at that particular project. And in our case, I think it was DynamoDB were not. It's not about this project. In a different case, it was about more like geo indexes. So we need a geo index, and it was not done in DynamoDB. So we migrated to Postgres. But this is nothing too overcomplicated. It's just a data migration to software redesign, just that. So DynamoDB is good for many things, but it cannot fit all the use case. Okay. Unfortunately, I don't have the data on comparing on-premises like CO2 or environmental impact with traditional. I didn't analyze that. So what's the difference between cloud and premises in terms of environment? Okay, please share your questions if you have some. I will wait for another minute. If there is no question, then thank you very much for your attention, and visit the CoffeeJUG talks next time.
Нас що-то обидвох буде, так?
Okay, there is another question from Oля. So does the service have to deal with the large amounts of data, like video processing, that can potentially exceed the runtime limits? How that will be handled? I think if we are using the CloudFront CDN, I don't think we may come up with any limits because that should be an Amazon scale solution if the CloudFront makes any limits for us. I didn't cover the topic of video processing, so this is a really deep topic. For that, there is a service in AWS called Elemental Media Convert. So this is like quite a separate use case. Like in AWS, you may have a video, and you may want your video to automatically transcode it to the multiple screen resolutions. Like you want a version of Full HD, you want a version of for mobile devices, you want a version with a low quality, with a high quality, and you can use this service and convert it to multiple resolutions. And you may use some open source video player that automatically adjusting, so it will download the particular quality depending on your network connection. So if we're talking about limits, then I don't think you have a limit, but you may have a high cost and for your user it could be a high cost, like if you're using a mobile device but downloading a full HD version. So there are some ways to optimize that cost, like making a low quality version, different resolutions version. And for the amounts of data, I think that, well, I think if we use serverless, it's pretty hard to reach that limit. So yeah. Like short answer is I don't know how you can exceed the runtime limits, but that will impact your cost, and there are ways to optimize the cost. Okay, any more questions?
So looks, thank you, Kostya. Probably you can choose the best one, and this one receives some activity bonus from us.
I think I like the question about the limits and the video processing, the last one.
So, okay, thank you guys for being with us. And charitable organization A-Team Ecoli. And the best question, the best question bonus will receive Ola, yes? Kostya?
Yep. Olga for the question.
Yeah, Ola, we will contact with you after this talk. And thanks for being with us. Join to us in our Facebook, Twitter, and Telegram. Bye-bye.